Hey guys, so today we're gonna talk about interpreting rates of change and slope. So the first thing you want to know is that a rate of change is equal to the change in y over the change in x, which means y2 minus y1 over x2 minus x1. So the thing about this is you need to be able to pay attention to identifying which one is y2 and which one is y1 in order to get the correct answer. So the rate of change is the mx plus b, it's the m, that's the slope. So that's what we're going to be looking for today. So let me just read the definition of the rate of change. The rate of change over a part of a domain of a function is the ratio that compares the change in y to the change in x over time in that part of the domain. Okay, so the thing that they're saying is it's literally a ratio of the change in y over the change in x, which is correct because that's how we're looking at this fraction right here. So I'm going to write a little table on the side, and we're going to figure out the slope, which is called the rate of change. So years after 2000, the year 2000. So this is the x value, and the cost, which is in cents, it's the y value. So we have a 3, 4, 6, 8, and 13. 37, 37, 39, 42, 46. Okay, so keep in mind these are cents, not dollars. So remember to, when you're labeling them, remember to label it with the correct unit. Okay, so now what we're going to do is find the rate of change. So y2 means that when you're looking like on a line, the y2 is the y that's coming after, and you subtract it with a different y that comes before. It can literally be the same, and instead the y2 can be negative, and it's completely fine. You just need to remember to use a value that comes after with a different forward. Okay, instead of thinking of it as a y after, you have to think of it as an x. So it has to be an x that is bigger subtracted by an x that is smaller. With that, you correlate. So pretend this is 2 comma negative 5. So you would use this 2, and so this y right here, let's say it's a negative 1 comma 3. Even though this is a bigger number than this, you would still correlate whichever x comes with whichever y. Just think of it like that. So the bigger x is y2, and whatever y comes along with that bigger x is the y2. Okay, cool. So now what we're going to do is we're going to be calculating the rate of change per these 2 years. So I'm just doing it for 2 years so I can just show y'all how it works. So we're going to do between 2006 and 2008. As you can see, that's right here. Sorry, oops, I slashed the data. Okay, it's like that part of the thing. Okay, so this is the x and this is the y. So it says y2 minus y1. The second x is right here. So we're going to go to this y2. 42 minus, and then the y1 is this one, 39 over 8 minus 6. And this gives you 3 over 2, which is equal to 1.5 cents per year. Per year because we're looking at years after, and cents because that is the unit right here. So this is the basis for how you find the slope. So I just told y'all that it's called a slope, and for some reason they didn't include it in the book until just now when I'm going through the next pages. So I will be now talking to you guys in terms of these graphs. So there's a graph drawn right here. It's just a little graph right there. Okay, it's not going to be to scale. It's not going to be correct. I just want to point out the ordered pairs. Okay, so these are the ordered pairs. So now what we're going to do is we're going to find the slope of this line. When you're looking at a slope of the line, at any given time of the line, the slope is the same. So that's why you can literally use any points available to you. Okay, so now what we're going to do is we're going to do y2 minus y1 over x2 minus x1. This is a very, very, very important formula for the future. So I highly suggest you remember it. Okay, so rate of change, not charge. Sorry, the N looks a little bad. Okay, cool. So now we're going to do the second y is the second x value, the higher x value. So this is the 3, which is higher than 2. So second value is 4. Minus the first value over 3 minus 2, because this x's. This gives you a 3 over 1, which is equal to 3. So in the equation, it would be a 3x plus a b value is equal to y. Sorry. That's why you need the 3. And this is important not just for this equation, but so many more equations later. Okay. So now we're going to do a homework problem. So find the slope of each line passing through the given points using the slope formula. To describe the slope, positive, negative, and or undefined. Okay, so all we're going to do now is I have a little graph here. I'll just list, let me just, ooh, that's really, still really bad, but that's okay. 2, 3. This is -2, -1. Okay, so first we are going to subtract y2 minus y1. Okay. So as you can see, there are 2 double negatives. So a double negative equals a plus sign. So 3 plus 1 is 4, and 2 plus 2 is 4, which gives you the slope of 1, therefore showing that it is a 1x plus b equals y. So now all it is you're saying that there's literally no slope. I mean, there is a slope, but it's just a value of 1. So that means whenever x is increased by 1, the y value is increased by 1 unless this b value right here has a like an actual value that is not 0. And in this case, we're showing that the slope is positive. It is not negative and it is not undefined. Okay, so now we're going to be interpreting the slope with a few larger numbers, but I think you can do it. Okay, so the first one is, so what they call this y2 minus y1 over x2 minus x1, there's so many different ways to describe it. So you can say slope, you can say rise over run, which is what a lot of math teachers commonly use previously, like in Algebra 1. More likely when you go towards the Algebra 2 spectrum and stuff like that, they use either slope or they use rate of change. So that is the other one, rate of change. Because if you are doing word problems, you need to use rate of change and not slope, because rate of change over time of like money or however, like whatever the problem is. Okay, so we are going to do a little problem right here. This is the x and the y. The x is the age and the y is the heart rate. The maximum heart rate. Sorry, max. Ooh, that's really messy. I'm so sorry. Okay, so there's a 20, there's a 50, 180, 150. Okay, so as you can tell, the y2 is this value, and the the x2 is that value, and the y2 is this value. What do you notice? The y2 is smaller than the y1. That's completely fine. It happens. It'll just show you something about the data. Okay, so 30 divided by 30 is 1. But since there is a negative here, you need to do something with this negative. Because a negative divided by a positive always gives you the outcome of a negative. So you're just going to put the negative beside the 1. This shows that the graph, when you're like drawing a graph, the line goes down this way, which shows that it's just decreasing over age or decreasing over time. In this case, it's over age. So the heart rate, the maximum heart rate is decreasing over age. So once you get closer to like 100, you will have a very low maximum heart rate, such as like 80 or something, just dependent. You can now predict the heart rate by, since that is the slope, it's -1 x. You don't need to write the 1 because you know it's there. Plus b equals y. So once you find this b value, you can literally determine the heart rate of any person of any age. Okay, cool. So we are going to do another problem in the next video, but thank you guys so much for watching. I hope you learned something. I'll see you next time. Stay safe.